Well, greetings students, good to be with you. We're going to get back on our project here again. We did our first part of this drill tap bore in Esprit Cam where we did the face milling and the periphery milling. And we'll go ahead and go through that to make sure that everything is still good with this. This will be session 2. We probably will be able to finish this entire, the rest of this in this session, so we're going to give it a shot. All right, so that looks good, and we're ready now to begin to machine the peripheries of the bores and the tapped holes here. So we'll start out with our tapped holes because we want to do our drilling and tapping and then drill these 3 holes in the center for pilots. There are other ways of doing this. We can use pocketing down here for all of this, and we'll talk about that later. But first, we're going to start out with just using contour and getting used to using that function for doing boring and counter boring. All right, so let's get started with this. I'm going to put this up into top view, and we're going to pick the chain that we want, which will be a P-top type chain, and that chain will cover all of the holes, including the center bores, with our number 3 center drill. So we'll say machining, solid mill traditional, and we're going to say drilling here. And we're going to go to our file here and pick up the number 3 center drill, put in our speeds and feeds, 2000, and our feed rate's going to be 20 point. And we're going to not use peck drill, we're going to use drill, a one-shot drilling operation at 0.200 deep. And the chamfer, no chamfer diameter tip is already included, that's yes. Our full clearance is 1, clearance is 100 thousandths. We can use clearance for return plane and last point return plane because there's nothing in the way, nothing that we can crash into here. This is going to be sitting in the vise, and the vise, the part will be sitting down inside the vise on parallels at 250 thousandths deep. So we will not have any kind of clamping on this at all. So there's no need to tell it to come up to, let's say, our full clearance. So there's no need to do that. We do have the full clearance will still be 1.0, but we really won't be needing it because we're setting these two to clearance. All right, it's a CAN cycle, and we're going to go ahead now and check this out. Go to isometric here, and we'll go ahead and just make sure that everything looks good on this. I changed this to transparent here, and that is easily done by just simply going up here to the simulation parameters and just check off transparent and hit update and say OK. So everything's okay with this. We're going to do the transparent just so that I can see how deep my drills are going to make sure they're going where they should. All right, so we got that done, and the next thing we want to do is we want to pick the chain that represents our 12 holes because I'm going to drill those about 850 thousandths so that we have enough depth to do our tapping operation. Our tapping operation requires a 1/2 inch full thread. We're going to need an extra 200 thousandths on that in order to get our full depth on that. So let's go ahead then and go back to the top view, and let's look at our features here and pick the next one, which is just the 12 holes, and say machining, solid mill traditional, and we're going to say drilling. And we're going to start out with our 257 drill this time. It'll be 1200 RPMs, and it'll be 20 inches a minute. This will not be a single type drill operation. It will be a peck drilling operation, and 100 is good here. Our total depth is going to be 0.850. Make sure that we get far enough down there that we can tap our hole and have some place for chips to go. Starting depth is 0. Use chamfer diameter, no. Tip is already included. The clearances are all the same as before. It is still a CAN cycle. So we should go ahead then and check this out to make sure that everything is good on that as well. So we can grab this, and we can, by just looking at this, you can see also how this is going to look, and you can rotate this and look at it, and you can see that it doesn't go all the way through the piece. And then we can still try this out. And you can also go to front view also, and that'll help as well. And take a look at what we have here. That looks pretty good. So we don't have to simulate any more of that. That should work well. So that's let's go back to top view. And let's go ahead and do the tapping operation next. So again, we'll pick the same chain. Machining, solid mill traditional. Again, it'll be drilling because drilling includes tapping. We'll change this to the 5/16 tap. We're going to put 600 RPMs in here. And you will see that it changes it to 33.333. So you can get your calculator out just to double check to make sure that Esprit Cam has given you the proper feed rate. It's 1 divided by 18 is 0.50555, and if we multiply that times 600, our feed rate should be 33.33, and that's what it is. So we're good there. Some of the students in last semester really messed up on these things here, and if you try to put something in here, like I can come in here and I can put anything I want in there, but it's just going to rip the threads right out of it. So it's not going to give you the 5/16 thread you're looking for. So you have to make sure that these two things work together. So don't be afraid to take your calculator and just double check to make sure that it's not remembering something that was put in there previously. And then for under the drill here, we need to make sure we set it to tap, and we want to make sure we go down here 0.650. All right. And that means that we need 200 thousandths at least because of the spiral point on the tap. So we have to go down an additional 200 thousandths in order to get a full 500 thousandths diameter thread depth. So that's why I'm doing that. Very important. Okay, the clearances are all going to be good here. It's still a CAN cycle. I'm going to say okay. I'm going to come up here to isometric, and I'm going to run this through and just make sure it all looks good. Under this, we should also change this to 5/16 Just make sure we label the operation so we know later that this was the tapping operation, and say okay on this. And now we can see now that we've got what we need here. This one here, it has 257 drill. We should change that to number 3 center drill. So number 3 C drill. All right, and say okay there. Facing, periphery rough, C drill, 257 drill, and 5/16 tap. All right, so we can go ahead now and we can check this out and see how this looks. And if we go to the front view, you can see here that you have this clearance down in here for chips. All right, so that looks good. So we're going to say stop on that. We're going to say top, and we're ready now to go ahead and drill these 3 holes here through so that we have a pilot hole for our boring and counter boring operations. Okay, the next thing we want to do then is choose. We have these chains up here already set. So if we start down here, that's the counter bore. That is the thread, and that will be the 921.9. So we'll say, well, we don't want to really do that, though. We want to make sure we do this P-top first. So let's go ahead and do that first. So it's machining, solid mill traditional, drilling, and we're going to choose the 257 drill again and set this to 1200, and we'll set this to 20. And this will be a peck drilling operation again. And our depth this time now is going to be 1.350. We know that the part is 1.250 thick with the extra 1/4 inch on the bottom here, sitting in the vise. So we want to make sure that we drill through all of that and make sure we clear that. Okay, the clearances are all good here. That looks fine. And we can go up here to isometric and just double check this. And speed this up a little bit. And we can rotate this and to make sure that it goes all the way through, and it does. All right. All right, so that takes care of our pilot hole. And we're ready then to do our bores. All right, so we'll go to top view again, and we'll start out with our 921.9. And you see that we're going clockwise here. And just for a minute, we discussed this together. This is actually the minor diameter, or represents the minor diameter of the thread. So we really don't need to do a finish operation on this. We can simply do a simple bore without a finish cut at 1/4 inch increments and go all the way through with it, going in a conventional direction. So that's what we're going to do. We're going to say machining, solid mill traditional. We're going to say contouring. And we're going to pick up our 1/2 inch end mill. 1200 is good. That's all good there. Number of passes, 1. I'm not going to do 2 passes here. Don't have that much to take out. A finish pass, no. If you set this to yes, you'll have to do a finish pass, which we don't need here, as we discussed. It's conventional. Width is good. Spiral move, no. No allowance on the walls or on the floors. The total depth is 1.350. To make sure we go all the way through. And we'll set this to 0. We don't have a starting depth here. Or I'm sorry, 0.25 that was correct. I thought it was down here. It's 250 incremental depth. Retract for eye depth, no. And read taper from feature, no. Tapered wall angle, 0. It's going to be cutter comp right on both of these cases, and we have to make sure that we pick up the correct compensation. So it's tool number 5 is the 1/2 inch end mill. So our compensation here, offset register 5, is good. You have to check this because Esprit Cam will not necessarily put in the right offset number for the tool that you selected in the beginning of this technology page, and that's something important to look at. The next thing is collapse for trimming, tricoidal move, no. Tool blend, no. Everything here should be set to default. Stay inside the feature, yes. And then lastly, you have your clearances here, which are all good. And as far as our entry, we're gonna plunge down, and then we're going to feed over, okay, to go into our G41, G42. And then feed over and then wrap it up. So these two are good. We're going to use position radius, and we're going to use 50,000. So you can put 50 in here. And when you click down here, it'll put it in there again, 0.05. And it'll make it 0.05 down here. And all we have to do now is tell it where the center of the bore is, and that's there and there. And we can say OK. Now, if we go up here to isometric, we can take a look at what that looks like. And we can make sure that it goes all the way through by going to our rotate view here. Left click and hold your key down, and yes, it goes all the way through. Go up here to top, view again, shut this off, and then we're ready to go to the next one. Now it's going to remember everything we did here, so all we really have to do is pick the chain here and say machining, solid mill traditional, contouring, and everything will remain the same except for the links category here under the lead in and lead out. We want to make sure we pick the center of this and then hit OK, and you can see that it puts in those same cuts. So we'll come over here and do the same thing with the third one. Machining, solid mill traditional, contouring. Again, we're going to pick the center. And say OK. And then we can go to isometric and just double check and make sure everything looks good so far. So we're going to start from the beginning. I'm going to speed this up a bit and let this fly. Okay, one thing we do need to change is the direction of our counter bores here. I noticed that it's going clockwise also. We really don't want it to go clockwise because these are counter bores, and this could be a bearing surface, so we want to make sure we get a good finish, and we want to make sure that we get a finished cut as well to make it accurate. So I'm going to go back in here and just change that. So I'm going to take this out. Got to get out of here first. And let's go ahead and put this in here the right direction. So we're going to go here and come down here. And that's going to make it go in the opposite direction, counterclockwise, which will be climb milling. And that's what we want. Do the same thing over here. And lastly, over here, the same thing. All right. Okay, so we finished this hole last, so we're going to go ahead and pick up the counterbore from here using the same tool. So we'll grab this chain, and we're going to say machining, solid mill traditional, and contouring again. And we're going to use the same 1/2 inch end mill. Speeds and feeds will be the same. You could change them if you wanted to, but this should be fine. The strategy is going to be climb milling. Okay. There will be a finish cut, so I'm going to say yes here. Stock allowance on the walls is going to be 0.00, 10,000. Stock allowance on the floors is going to be 0.01. Okay. The depth is going to be 0.250. and the incremental depth will be 0.125. Now this time we're going to be cutter comp left, so we want to change this to cutter comp left. And it's still tool number 5, so offset register should also be 5. Now it's asking us to put in our finish speeds and feeds, so I'm going to use 1200 just the same, and I'm just going to slow down the feed rates a little bit to give it a better finish. It's going to be still considered climb milling, and we want this to happen after all the roughs, okay? All roughs or each individual rough. So we want to make sure that this happens after all the roughs are done and at the last Z level. Very important here. So you're only making one final cut at the depth of -250 and going around and doing the wall finish at the same time. All right, so that's all taken care of. And then tricoidal move and trimming will stay the same. Nothing's going to stay inside the feature. That's going to stay the same. And of course our clearances and our entry and exit will be the same. Composition radius will be the same, and we'll just simply pick the center of our counterbore. And we're going to say OK. And now we can take a look at this to make sure it all looks good. So we'll go ahead and I'm going to open this up here for a minute. And I'm going to change the label here, or the operation name, to 1.250 bore, C bore. Okay, and say OK there. So now we have that separated, 1.250 C bore, and now we can just test this out. That looks good. All right, so we'll do the next two, and that'll take care of the bore and the counter bore for each of them then. So we'll grab this one here next. Machining, solid mill traditional, contouring. Again, everything should be the same here. You shouldn't have to change anything here except for your approach. So you come down here to links and you'll pick the center of the bore here. And say OK. And then come over here and do the last one. Machining, solid mill traditional contour. And again, we're going to pick the center of the bore here. And say OK. All right, so I think we should check everything to make sure that we're good. Make sure you save this. And as we mentioned the last session, that we should file save as and put this in your files. That's on your desktop. And make sure that you have a category for your machining operations of those labs. All right, so we're going to test this out here and see what we have. I'm going to go ahead and let this speed through here. Tapping operation, drill through, bore through, now what we could do is double check this. So we can use the rotate again, and we can zoom in here and make sure everything looks good. Also want to rotate underneath here and make sure that those bores go all the way through and everything looks like it's in place and where it should be. And now we'll go ahead and say isometric again. Now, if you want to get rid of some of the squiggly lines here, you can always go up here, and instead of having it set to plot geometry, uncheck that, and then say OK. And then when you do this, it's not going to have all those lines in here. And you may want to do that just for clarity purposes, which is not a bad idea at all. You're going to need your lines there to pick your chains, of course, but for the purpose of simulation, getting rid of those lines helps a lot. It sort of gives some clarity. You can see now a little bit better at the threaded holes here. And now you can take a look at this a little bit better and see what you have. So you may want to do that. Transparent's great because you can see everything right through it. So I'm going to say OK here, and I'm going to go back to top. And now I'm going to do my final operation, which is going to be the thread milling operation. All right, so we finished up here, so I'm going to start with my thread milling operation right here. So I'm going to choose the dotted line chain, machining, solid mill traditional, and this time I'm going to pick threading. All right, so we want to make sure we pick up our 0.500 by 0.0833 pitch thread mill. I have it set at 600 for our speed, and 10 and 10 is good here. Strategy is going to be internal right-hand turn, right-hand movement, okay? And the major diameter here is 1 inch. Minor diameter is 0.9219. And the total depth we want to go is 1.350 because we want to make sure we go through the extra material on this thickness of our piece with the thread. Strategy here is going to be conventional because it's going to be going like this, right? And we're going to go machining direction is going to be down, and our start angle will be 0. That's over here. We're going to use arcs. There is the possibility of using segments, and that takes a long time. So you want to just choose arcs. Tolerances of 1/10 is great. Stock allowance, no stock allowance on anything. And we want to make one rotation. We want it to go all the way down and go around one time and get out of there. So our compensation is right. We have to make sure that our register NC is correct, so we can go over here and look at which one is our thread mill, and that it is, there it is right there. So 6 is good for our offset register. And then links, lastly, our clearance will be the same. We want to start and end from the center of the hole. It knows where it is, it just needs to know that that's where you want to start and end. Tangential arc, yes. Lead in, lead out angle is going to be 90. Edge clearance 20 thousandths. And feed entry feed rate 100%. And I'm going to say OK here. And go ahead and just simulate this just to make sure this looks good. And I can do this single step here so I can see what's going to happen. It goes all the way down, makes one rotation, and then comes back out. So that's what we want. So let's go ahead and, while we're doing this, just go ahead and do the other ones just as, right at this moment. So that's, we keep moving on this. And go machining, solid mill traditional, and we're going to go threading. And again, we don't have to change anything here. As a matter of fact, we don't even have to put the center of the hole because it already knows where that is. So it's going to put the spiral in there where it needs to, so we can go right over here and do this one real quick. Machining, solid mill traditional, and threading. And we're going to say OK. And now we can go ahead and look at the complete part and make sure that everything checks out. Transparent is also good to see that your threads are actually penetrating. So that's going to be evident to us in a moment here. And I'll show you why that's so beneficial. All right, now if I rotate this and I zoom in on this, you can see how that my thread mill is actually penetrating the wall and creating our thread on all of these. That's why transparent is so good. If I would do this without the transparent, you would not see that very clearly. So if I went to solids here and I unchecked transparent, hit update and OK, and then just did one of the threading operations, you can see what you're going to have here. You're not going to be able to see really anything as far as the penetration of the thread, even if we rotate it. So I can rotate this all I want, and you can see that it's not going to give me a whole lot to go on. So that's why it's really a good idea to stick with transparent. You have to always hit update when you change something, and then all of a sudden you see everything the way it's supposed to be. All right, well, it looks like we're going to be able to finish this in 2 sessions. So we got everything finished here. You can take some time on your own now if you have to do some tweaking or whatever you may need to do. And I'm going to sign off with this now, and have a good day, and I'll talk to you soon.